Today the subject for today is Spark. So we will have an overview of Spark. What is Spark? What it is used for? The software stack of Spark, its internal architecture, and the type of services and libraries that it provides. We will also look briefly at the Scala programming language. So what is the problem and why the Spark was created? We already know that the problem is we have a lot of data. Data is growing very fast, faster than the current computing powers that we have to process the data at satisfactory speed. And so one solution is what we have already seen, is to create a cluster of computers and to have the computation run in parallel. We have seen some MapReduce programs before. So one way to do this computation was with Hadoop and MapReduce to do the distributed computation. However, the creators of Hadoop and MapReduce have noticed that it does not perform well with certain jobs that it has to do. And so the next improvement over the MapReduce is Spark computing engine, which speeds up the processing of these particular jobs that were running slower on MapReduce. So we will look at what are the limitations of MapReduce and why we created Spark, and we will see example comparison between the two when they do machine learning on particular data. And then we will see the tools which Spark provides and its built-in libraries. So the problem is that we have a cluster of computers. These computers need to pass messages between each other. They're connected through a network. And so when that happens, that takes time. So message passing between the nodes or the nodes of the cluster can be slow, and it is difficult to scale. So we have been thinking how to reduce the amount of data that has to travel through the network and more have processing done on the nodes themselves, and to reduce this message passing. So other things that need to be considered, how to deal with failures, because failures will happen because these are commodity machines. And so we need to expect a failure and be able to deal with it. So we have just two problems: slow network and failures. So what the MapReduce did, we have already seen that. It restricts the programming interface so that the system can do more automatically. And we can express jobs as graphs of high-level operators. So we have the mapping function and the reducing function, and each mapper can use one or more reducers. And we run, and we do have fault recovery, because we keep pieces of the data in 3 copies. So the system will pick up how to split each operation into tasks and where each task should go, so into which mapper, and then the reducers are invoked. So that's one example to use this MapReduce. Some algorithms that can run via the MapReduce is matrix vector multiplication, PageRank, and some gradient computing methods, and also some statistical methods, stochastic methods. So this type of data flow engine we're using because it's easy to program. They are high-level functions instead of us having to worry about passing the actual messages between the nodes as a programmer. Scalability, it can scale to very large clusters, and there is resilience because we can recover from failures. So the tools that use this MapReduce is Pig and Hive, what we have already seen. So that was a special programming language. This is the tool that allows us to run SQL queries on data in a MapReduce environment. And then we also saw this storm that allows us to do streaming data processing. So this is great. What are the issues with the MapReduce? So MapReduce is great for one-pass computation. However, if we have to do multiple, so once we pass the data and let it do its computation and it works fine. But if it happens that we need to do multiple passes, then it is not very efficient. It's also not very good for data sharing. And the reason it's not good is because it's very slow, because it has to replicate things and needs to access the disk every time that to store the data. And as you know, I/O operations, input-output operations go on the disk and back is very slow. So iterative applications. We said, if we pass the data one time and let the MapReduce do its job, it works fine. But if we have to do multiple passes, such as you have many iterations, then it spends like 90% of its time doing I/O operations, which means accessing the disk and storing data and retrieving data from the disk, which is very slow operation from point of view of the CPU speed. So let's say he needs to read, goes to the disk and read iteration 1, then has to write, goes to the disk to write, again has to read, reads from the disk, has to write, goes back to the disk to write, and all of that slows it down considerably. If it's done in one pass, then it works fine. So if it has to do page ranking, and it's also not very good because it needs to do multiple iterations. So there is iteration 1, it looks at the neighbors and ranks them by ID and rank, then has to do second iteration, third iteration. And so the same file is grouped over and over, and it requires repeatedly hashing together page lists of neighbors or adjacent lists in order to create this ranked vector. So it doesn't work very efficiently for an algorithm like that. So MapReduce is simple, but it can require a lot more computation when it needs to do multiple passes and iterations because of the I/O. So the solution is to create a new computing engine. And that's what Spark is. So Spark is a fast and general purpose cluster computing framework for large-scale data processing. So it is designed to be fast and general purpose. And so it extends the popular MapReduce model because it efficiently supports more types of computations, including these interactive queries and stream processing. So the speed is important in large data sets. It makes a very big difference for exploring data interactively if we have to wait minutes or we have to wait hours. So one of the main features that Spark offers for speed is its ability to run computations in memory. And so the system is also more efficient than MapReduce when it has to run computations on the disk. So the Spark is designed to cover a wide range of workloads, which before, if we had to use MapReduce, it will require, the MapReduce requires a distributed system, and it has to combine interactive, so it has to do batch processing in that distributed system, but now we can handle interactive queries and also streaming much easier. We can also combine different processing types if we have to create production pipelines. So the Spark is designed to be highly accessible. It offers simple APIs for Java, Scala, and Python, and also R, so it is easy to access and to use. It also has its own support for SQL, so it has a Spark SQL, and it also has a bunch of built-in libraries, so it's rich in built-in libraries. It can integrate closely with other tools, so this is, like we said, it can integrate with Hadoop. If you have that installed already, it can integrate with it and with the Hadoop distributed file system.